Today, I will be walking you through how to use the double angle formulas for sine, cosine, and tangent. First up is the formula for sine. Take a moment to pause the video and write down this equation for future reference. Our first example is simplifying the expression 2 times sine of 27 times cosine of 27 using the double angle formula. As we can see, this expression here matches that of our double angle formula for sine of 2x. Thus, we can conclude that x is equal to 27. This equation just simply shows that sine of 2x is equal to 2 times the sine of 27 times the cosine of 27. From here, we can plug 2 times the sine of 27 times the cosine of 27 into the calculator to get sine of 2x is equal to 0.809. From here, we must isolate x in order to refigure out x. As we already know that x is equal to 27, this will simply reaffirm that x is indeed equal to 27. To do so, we will divide sine of 2x by sine and moving it over to the other side. To successfully do this, we will then take the inverse sine of 0.809, and to further isolate x, we will divide that by 2. Thus, x is equal to the inverse sine of 0.809 divided by 2. Plugging this into the calculator, we will confirm that x is equal to 27. If we plug this into sine of 2x, thus sine of 2 times 27, we will get sine of 54. Thus, our simplified expression for 2 times the sine of 27 times the cosine of 27. Next up is our formulas for cosine. Take a moment to pause the video and write down these equations for future reference. Our next example will be finding cosine of 2x if sine of x is equal to negative 12 over 13 in quadrant 3. By telling us that this is in quadrant 3, we now know that both sine and cosine will be negative values. The equation that best fits our need is to find cosine of 2x is cosine of 2x is equal to 1 minus 2 times the sine squared of x. As we already have our sine of x, we can simply plug negative 12 over 13 into this equation, giving us 1 minus 2 times negative 12 over 13 squared. By squaring negative 12 over 13, we will get 144 over 169. And to further simplify this expression, we multiply 144 over 169 by 2. From there, we need to give 1 a common denominator, or the same denominator as 288 over 169. Thus making it 169 over 169 minus 288 over 169, giving us negative 119 over 169, which is approximately negative 0.70. Thus, cosine of 2x is equal to negative 0.70. Our next formula will be the double angle formula for tangent. Pause the video and take a moment to write down this equation for future reference. Our last example is tangent of 2x if sine of x is equal to 3 over 5. First, we have to figure out what tangent of x is, and to do so, we will divide the sine of x by the cosine of x. Because we already have sine of x, we now must figure out what cosine of x is. And to do so, we will be using the equation sine of x squared plus cosine of x squared is equal to 1. From here, we will square 3 over 5, as that is our sine, and add it to the cosine of x squared, which then equals 1. In order to isolate cosine squared x, we will subtract 9 over 25 from both sides, giving us 16 over 25. Because cosine of x is squared, we must figure out the square root of both sides, giving us cosine of x is equal to 4 over 5. Plugging sine of x and cosine of x in to figure out our tangent, we get that tangent is equal to 3 over 4. We will now use our tangent and plug it into the double angle formula for tangent. By plugging in these values, we get the tangent of 2x is equal to 2 times 3 over 4 divided by 1 minus 3 over 4 squared. Simplifying this down, we get 6 over 4 divided by 1 minus 9 over 16. Giving 1 a common denominator, we are now left with 16 over 16 minus 9 over 16, which is equal to 7 over 16. Thus, 6 over 4 divided by 7 over 16. When dividing fractions, you flip the denominator and multiply it times the numerator, giving us 6 over 4 times 16 over 7, which is equal to 96 over 28, which is approximately 3.42. Thus, tangent of 2x is equal to 3.42. Thanks for watching, guys.